NASA is doubling down on its quest to conquer one of the Moon's most challenging frontiers, the lunar South Pole. This time, the agency is partnering once again with Firefly Aerospace, the company that recently made history with their successful Blue Ghost 1 mission, landing on the Moon in March. As of now, Firefly is the only American company to have achieved such a feat in recent years, a significant distinction as the new space race accelerates. But this next mission, it's on a whole different level. Unlike previous landings in the Moon's smoother northern hemisphere, this mission targets the rugged, shadow-choked terrain near the lunar South Pole. It's a region fraught with deep craters, unpredictable terrain, and extreme lighting conditions. Reaching it is no small feat. In fact, Intuitive Machines, another American space company, has attempted to land there twice in the past 2 years and failed both times. Still, NASA believes Firefly is up to the challenge. That's why they're entrusting the Blue Ghost lander with 2 major scientific payloads, a pair of next-generation lunar rovers. The first of these robotic scouts is called Moon Ranger, a collaboration between NASA's Ames Research Center and Carnegie Mellon University. Moon Ranger is a compact rover, roughly the size of a carry-on suitcase. But don't let its size fool you. It's built for autonomy. Using stereo cameras and a sophisticated onboard mapping system, Moon Ranger will be able to explore the lunar South Pole without any real-time control from Earth. Its main goal? To search for water ice, the holy grail for future lunar colonization. Joining Moon Ranger will be a second, currently unnamed rover developed in Canada. This 4-wheeled platform is also designed for independent surface exploration. It will carry instruments to detect signs of water ice, monitor radiation levels, and measure temperature variations in the deep shadows of the South Pole. Unlike most solar-powered rovers, this one carries a battery large enough to power it for up to an hour inside the Moon's permanently shadowed craters. That's where scientists believe the highest concentration of water ice may be hiding, untouched for billions of years. Even more impressively, the Canadian rover is designed to withstand the brutally cold 14-day lunar night and restart operations when the sun returns. The Blue Ghost lander itself will also carry 3 powerful scientific instruments: LIMS, LIMS, the Laser Ionization Mass Spectrometer. This device will use a robotic arm to scoop up lunar regolith, then blast it with a laser to analyze its atomic and isotopic makeup. Stereo cameras for plume studies, designed to observe how the lander's descent engines disturb the fine lunar dust, helping scientists better understand the Moon's surface composition and behavior. Laser Retroreflector Array, a passive device that lets scientists bounce lasers off the lander from Earth to precisely measure its final position. This high-stakes South Pole landing is scheduled for launch no earlier than 2029, and it marks Firefly's most daring mission to date. But it's just the beginning. Even before the success of Blue Ghost 1, NASA had already selected Firefly for additional missions under the Commercial Lunar Payload Services (CLPS) program. Up next, Blue Ghost 2, slated for launch next year, will target the far side of the Moon, a region often dubbed the dark side, though it receives sunlight just like the near side. What makes it unique is that it's never visible from Earth. Blue Ghost 2 will first deploy the European Lunar Pathfinder satellite into lunar orbit to establish communication links, then land in a far-side region carrying the Lunar Surface Electromagnetics Experiment, NITE, a radio astronomy payload designed to use the Moon's mass as a shield from the Earth's radio noise. From there, it will attempt to peer back in time, observing the early universe in frequencies we can't detect from Earth. In 2028, Blue Ghost 3 will head to the Gruithuisen Domes, a baffling geological region in the Moon's northern hemisphere. Most of the Moon's surface is basaltic, formed by thin lava flows. But the domes are made of thick, sticky silicate lava, a type of rock formation usually associated with tectonic activity and water. But the Moon has neither tectonic plates nor liquid water. So how did these domes form? That's exactly what Blue Ghost 3 will investigate. The mission will carry 6 scientific instruments, including a rover built by a yet-to-be-named industry partner. One contender is a design collaboration between Interlune and Astrolab, an advanced rover platform equipped with a very special kind of search. The Interlune Astrolab rover has its eyes on something extraordinary: helium-3. This rare isotope is thought to be a potential game-changer in nuclear fusion, offering clean, nearly limitless energy. Using Astrolab's Flex rover platform, the team plans to tow a harvesting instrument developed by Interlune. A pilot version of this rover is scheduled to land as early as the end of this year via the Astrobotic Griffin lander, launching atop a Falcon Heavy rocket. In this first mission, the rover will use a special NASA-developed camera system to scan for helium-3 by identifying titanium-rich minerals, indicators of helium-3 presence in the surrounding lunar regolith. Assuming the first test is successful, Interlune plans to return in 2027 with an upgraded rover specifically designed to collect physical samples from areas deemed ideal harvesting sites. Interlune isn't just collecting for the sake of science, they're already building a business model. The U.S. Department of Energy has signed an agreement to purchase up to 3 liters of helium-3 by 2029. Even more impressive, a startup in the quantum computing space, Maybell, has expressed interest in acquiring thousands of liters annually between 2029 and 2035. That demand could make helium-3 not just a scientific curiosity, but a resource with immense economic potential. Quantum computers, national defense systems, and even advanced medical imaging applications could all benefit. Today, Interlune remains a small startup with just 25 employees, but they're positioning themselves to become America's first commercial moon mining operation. And they're not stopping at helium-3. Their long-term vision includes extracting rare earth elements, industrial metals, and lunar water to sustain a permanent human presence on the moon. To achieve that, they claim to have patented technology to allow for lighter, more efficient lunar systems that require up to 90% less power than existing alternatives. That innovation has already attracted over $18 million in early funding. This is only the beginning. With Firefly building the lunar landing infrastructure and startups like Interlune preparing to tap into lunar resources, a new space economy is on the horizon. Sure, the focus right now is still science and exploration. But as history has taught us, where there are valuable resources, industry soon follows. The moon may soon become more than a symbol of exploration. It could be the next great frontier of industry and innovation. We're witnessing the next giant leap, not just for NASA, but for private space exploration and lunar industry. From robotic rovers sniffing out water ice and helium-3 to lunar mining startups already signing contracts with government agencies, the moon is about to get busy. So the real question is, are we ready? If this glimpse into our lunar future fascinated you, help support more deep space content like this. Like this video, hit that subscribe button, and turn on notifications so you never miss the next mission update. And share this video with anyone who still thinks the moon is just a dead rock in the sky. They're about to be proven wrong.